Question 19, Part A. We're given a function of n, which is 3 to the n plus 2 plus negative 1 to the n times 2 to the n. In Part A, we want to show that 2f n plus 1 take away fn is divisible by 5. So this is f of n. F of n plus 1 would be 3 to the n plus 3 plus negative 1 to the n plus 1 times 2 to the n plus 1. So 2f n plus 1 take away fn would be 2 times 3 to the n plus 3 plus negative 1 to the n plus 1 times 2 to the n plus 2. So that's the 2 times f of n plus 1. Then we're taking away 3 to the n plus 2, take away negative 1 to the n times 2 to the power n. Now, 3 to the n plus 3 is 3 times 3 to the n plus 2. So this is 6 times 3 to the n plus 2. Take away 3 to the n plus 2. Then we have 2 to the n plus 2 is 4 times 2 to the n. So that's 4 lots of negative 1 to the n plus 1 times 2 to the n. We know that negative 1 to the n will alternate in sign. So if we have negative 1 to the n plus 1, that's going to be minus negative 1 to the n. So this can become plus negative 1 to the n plus 1 times 2 to the n. So that gives us 5 times 3 to the n plus 2 plus 5 times negative 1 to the n plus 1 times 2 to the n. And we can take out the common 5. So that's 5 into 3 to the n plus 2 plus negative 1 to the n plus 1 times 2 to the n. Now in part B, we're told hence or otherwise prove by induction that fn is divisible by 5. I decided to go otherwise. F of 1 is 3 cubed minus 2, which is 25, which is 5 times 5. So we have true for n equals 1. Now for the inductive step. We're going to assume for n equals k. So that will be 3 to the k plus 2 plus negative 1 to the k times 2 to the k is equal to 5a for some integer a. Now we need to consider the next case. So we're going to consider for n equals k plus 1. So that's 3 to the k plus 3 plus negative 1 to the k plus 1 times 2 to the k plus 1. So that gives me 3 lots of 3 to the k plus 2. Take away 2 lots of negative 1 to the k, 2 to the k. So I've split a 2 out of the 2 to the k plus 1, and I've used once again the fact that the signs will alternate. This could be written as 3 times 3 to the k plus 2 plus 3 lots of negative 1 to the k, 2 to the k, take away 5 lots of negative 1 to the k, 2 to the k. The 3 take away 5, giving me the minus 2 here. So this is 3 lots of 3 to the k plus 2 plus negative 1 to the k, 2 to the k, take away 5 lots of negative 1 to the k, 2 to the k. And in the bracket here, we have 5a. So that's 3 lots of 5a, take away 5 lots of negative 1 to the k, 2 to the k, which is 5 lots of 3a, take away negative 1 to the k, 2 to the k, which is divisible by 5. And now all you need is a closing statement.